Problem 6, we need to determine the horizontal and vertical components of reaction at pin B. Members AC and BC are pinned together at point C. So you need to recognize that this is a machine and frame problem. You have two rigid bodies, AC and BC. They are pinned together. You can separate them. You can draw the free body diagram of AC. You can draw the free body diagram of AC and draw the free body diagram of BC separately. And what's going to happen is that you realize that point A, you have AX and AY, two components, support components, because of the pin support. At point C, you also have CX and CY, two components. And then for member BC, you have BX and BY here. Okay, you have the applied 120 Newton meter moment here. You have again applied force 300 Newton here. And at point C, you have action and reaction. So CX now in the opposite direction and CY in the opposite direction. So now you realize that you have two rigid body free body diagrams. Remember, for each one of them, this is a 2D problem. For each one of them, you can write 3 equations. So together you can write 6 equations. You can solve for 6 unknowns. And you do have 6 unknowns. You have AX, AY, CX, CY, BX, BY. So you can set up your 6 equations and solve for them. However, if you recognize that AC is actually a two-force member, you will realize that the force associated with AC has to be in this direction along the orientation connecting these 2 points AC. For that reason, and don't forget, you actually are not asked to solve for the force in AC. You are asked to solve for the forces associated with the pin support at point B. So for that reason, you only need to draw free body diagram of member BC alone. Okay, so recognize that this is a two-force member. We can draw only the free body diagram of member BC. Again, you will have your BX and BY, two support associated with the pin support. Again, you have your 120 Newton meter applied couple moment. You have your 300 Newton force. But now here, I'm just going to draw my force that is at a 45-degree angle, and that is my FAC. How do I know it's a 45-degree angle? Because I have 1 meter and 1 meter here. Okay, so this FAC is our third unknown. So one free body diagram for a 2D rigid body. We can write 3 equations and solve for 3 unknowns. And let's do that. Resultant force along the x direction. We will have our BX plus our FAC has a horizontal component, cosine 45 degree, okay, minus our 300 Newton force, also have a horizontal component of cosine 45 degree, and that equals to 0. Resultant force along the y direction equals to BY, FAC with the sine 45 degree component, which is the same as cosine 35, plus the 300 Newton, because the vertical component is going up, sine 45 degree. All right, lastly, we can summarize the moment about point B. And BX, BY don't have moment about point B. We have the applied positive 120 Newton meter couple moment. All right, the force Fc, only the x component creates moment about point B, and it's clockwise, so negative FAC times cosine 45 degree times the moment arm of 1 meter, and then the 300 Newton x component causing moment about point B counterclockwise, so plus 300 Newton cosine 45 degree times moment arm of 2 meter, and that equals to 0. Okay. With that said, we can solve for all three of them. So our FAC equals to 770 with a dot indicating three significant figures. BX is going to be negative 332 Newton. And lastly, BY is negative 756 Newton. So really only the last two are what we're asked to find out. So that should be the faster way to solve this problem, but you can definitely try to break this frame into two rigid bodies, set up your overall six equations to solve for your six unknowns. You should be able to get the same answer as well. However, if you recognize that member AC is a two-fourths member, it should simplify the calculation procedure for you.